The 25 rupees harvester doesn't just cut, it measures, grips, and delivers logs in one controlled sweep. Mounted on the Fiat 82-94 tractor, it operates using the original hydraulic pump that pushes around 30 liters per minute. This flow drives the Palm's 5.85 loader, giving smooth motion and firm control. To prepare for cutting, the operator positions the head precisely against the trunk. The RS-25's blades close in, gripping and slicing through cleanly before the log is laid onto the trailer. You'd be surprised how steady the Fiat stays even when lifting an uneven load. The delimbing knives strip branches quickly, leaving uniform logs ready for stacking. Hydraulic coordination keeps every motion fluid and consistent. By balancing human judgment and machine force, the system maintains speed, safety, and reliable production across each harvest. This machine doesn't waste a second. It slices and halves each log like it's built for speed. A hydraulic arm loads each log upright into a steel chamber, locking it into position with firm pressure. What happens next is pure efficiency. The log is sheared and split in one motion, dropping clean halves in seconds. You almost want to blink slower just to catch how fast it finishes. A short hydraulic tube guides each log into the cutting zone, ensuring every piece stays aligned. Once engaged, the circular blade slices through the wood, while a wedge below divides it evenly. That dual action is what makes this setup so satisfying. No pause, no hesitation, just perfect timing. Operators only need to control feed speed, and the rest runs almost automatically. One lever manages the whole operation. Proof that simplicity can outperform size. The constant motion between lift, cut, and split keeps productivity high without wasted energy. Somehow, the balance between brute force and smart design feels just right. It's compact, direct, and practical, the kind of build you'd trust for long winter workdays. Even the sawdust discharge looks organized, like the machine insists on neatness. End of the day, piles of firewood stand ready. Machines like this remind you that sometimes real craftsmanship lies in getting the job done cleanly and fast. What kind of hydraulic setup lets a skid steer rotate full-length logs without losing grip? The opening motion clamps firmly around the log, locking it in place. Hydraulic rotation follows, adjusting each angle for lifting, loading, or stacking. The Fiat 82-94's original pump supplies about 30 liters per minute, giving the system steady flow and strong torque. Kind of wild seeing a small machine lift a log that looks twice its weight. Operators use the joystick to rotate the grapple. position the load, and release it smoothly. The Palm's 5.85 loader frame gives extra reach and stability, especially when moving heavy trucks. You'd think those logs might roll off, but nope, they stay in perfect control. Each motion is responsive, keeping the grapple balanced during uneven terrain. The hydraulic lines are reinforced to handle constant pressure, minimizing maintenance needs. Designed and built in Canada, the setup delivers consistent performance for forestry, yard, and land clearing work. In the end, this attachment turns a standard skid steer into a reliable timber handling powerhouse. The thud of an axe and the buzz of a saw mark another day of crafting wooden walls that will stand for generations. Each movement in this Russian workshop reveals the union of raw timber and skill, turning rough pine logs into a home's sturdy skeleton. Using Carelia pine with natural moisture, the builders work with precision tools and steady hands to ensure every cut aligns with the timeless style known as Russian cup-joinery. The process opens with log selection. Every trunk is examined for straightness and density, essential for strong corners and tight fits. Once chosen, logs are peeled and debarked using mechanical knives, leaving the surface smooth, yet preserving the natural contour. You'd never think raw logs could look this refined without a single coat of finish. Each piece is then measured and marked to determine where joints will interlock. Next comes the hallmark of this technique, carving the cup joint. Specialized chainsaws and hand tools hollow out curved notches at each log's end. This allows one log to rest perfectly atop another, locking the structure through gravity and geometry. Feels like ancient geometry class, but way louder. The builders constantly test the fit, adjusting with chisels until every notch seals tightly. Afterward, the corner joints are refined, ensuring the natural insulation of wood fibers remains intact. The logs are stacked layer by layer, forming walls that stand without metal fasteners. Imagine stacking giant wooden puzzles, but each piece weighs 100 kilos. That's real dedication to the craft. Every adjustment feels like a conversation with the wood, subtle, demanding, and full of patience. Openings for windows and doors are marked and cut with wide saw blades, maintaining balance and structural tension. The entire assembly is later disassembled, numbered, and transported to the final building site for reconstruction. This modular approach allows perfect alignment even after relocation. Carelia pine, known for its resin content and durability, adds longevity to the structure while preserving that authentic wooden aroma. Builders treat contact surfaces with protective oil to resist moisture while keeping the timber breathable. One wrong swing and the whole corner might need a redo. Talk about pressure on the craftsman. Still, their focus never wavers. Every completed frame stands as a testament to patience and skill. No digital modeling here, just experience, geometry, and trust in wood. These homes breathe, settle, and age gracefully, holding the warmth of tradition within every notch. The scent of pine mixes with the growl of a chainsaw as each cut reveals the heart of the log. Using a steel power saw, the craftsman slices through massive trunks with practiced ease, shaping beams that will later become part of a wooden house. Every motion balances speed and control. A millimeter off, and the entire cut loses value. Each trunk is secured on supports before cutting, ensuring stability and even pressure. The saw moves along chalk lines that guide every section. You can't ignore how consistent torque keeps the blade steady, even through dense Carelia pine. Logs are cut into segments, measured, and retrimmed for alignment. Sawdust fills the air, but the rhythm never breaks. When the chain catches for a split second, you can almost feel the heart skip too. Then relief when it roars back to life. Each finished beam holds both raw strength and the mark of steady craftsmanship. Few people realize how much precision engineering goes into cutting a single pine log. Inside the production line, that complexity turns into seamless motion across every step. Here in Madeira's Estanqueiro, Spain, Galician pine logs move through one of Europe's most efficient primary processing systems. Each trunk is positioned on an inclined carriage from Barton Maquinaria SL, designed to handle varying diameters with remarkable grip and balance. This setup ensures every cut is clean and consistent for the next stages of lumber production. The carriage advances the log toward a circular saw that slices through the dense pine with high torque. Cut after cut, the wood reveals its core layers, soon to be squared into usable boards. Hard not to admire how fluid the sequence looks, industrial efficiency at its finest. After the primary cuts, side slabs fall away, while the main beam continues forward for resawing. These rough planks are aligned for secondary trimming, giving each piece a uniform finish, suitable for later drying. Someone probably thought this machine was slow until they saw how fast it handles a full trunk. The boards then move to sorting conveyors, where pieces are graded by width and quality. Operators monitor thickness readings and adjust the feed instantly. That level of responsiveness really shows how much trust exists between people and machines here. Once complete, the pine lumber is stacked and prepared for the drying kilns, marking the end of its first transformation stage before entering finishing lines. Kinda makes you realize how much work stands behind every polished piece of wood in construction. Built with local pine, skill, and Spanish engineering, this mill keeps tradition alive, while relying on modern automation to maintain output day after day. Each day, hundreds of logs meet the Robel 250, a machine built to strip bark faster than a crew could ever manage. Its rotating head removes bark cleanly, exposing the natural grain beneath. The feed rollers grip each trunk tightly as the hydraulic pressure adapts to different diameters. That roller looks like it's having a workout of its own. Once stripped, the smooth logs continue down the line for sorting and inspection. The machine's automatic feed ensures continuous flow with minimal downtime. Crazy torque on that head. No wonder it eats bark like snacks. Operators monitor control panels to fine-tune speed and pressure, maintaining a steady rhythm of productivity. Designed for both hardwood and softwood, this system maximizes yield while reducing maintenance needs for sawmills that process thousands daily. The sight of spinning blades shaping timber into smooth cylinders never loses its appeal. In the TRIQ production facility, this process unfolds through precision-driven equipment that shapes, smooths, and aligns each piece for construction use. Logs are first debarked to remove rough outer layers, then pass through a milling line that gradually rounds their surface. The shaping head carves away excess material with controlled rotation, forming uniform cylinders. That cutting head moves like it's trimming a giant pencil. Conveyor systems feed each log seamlessly toward the calibration unit, where dimensions are refined to millimeter accuracy. Operators supervise console screens, monitoring feed rates and tool engagement to maintain balance between speed and finish quality. Always wild seeing wood treated with such technical calm. Once milled, the logs advance to chamfering, where their edges are smoothed for easy stacking and precise fitting during construction. The system's automation keeps production consistent while minimizing material waste. Each completed log is inspected for straightness and surface uniformity before stacking. Moisture levels are also checked to ensure durability and stability in future structures. Some are treated with protective coatings to resist weathering, extending their service life. The TRIQ facility combines traditional woodcraft knowledge with automated accuracy, bridging manual craftsmanship and industrial efficiency. Honestly, seeing those rounded logs roll out one after another feels oddly satisfying. The steady tension of a blade slicing through timber carries its own kind of satisfaction. This homemade bandsaw proves how engineering skill and pure practicality can turn raw logs into clean lumber without a factory line. Built from welded steel and powered by a belt-driven motor, it's a perfect balance of invention and simplicity. There's a certain respect owed to machines like this. Ones made not for show, but to work hard and last. You can tell this machine was built with real understanding, not just assembly. The process opens with securing the log onto a rolling bed. Adjustable clamps hold it tight while the operator measures the first cut. You can almost hear the focus in the way the operator steadies his hands. A quick spin of the handle aligns the guide, and the bandsaw blade hums into action. Each pass removes a slab, revealing smooth grain beneath the bark. The homemade rig runs surprisingly stable. Whoever built it knew the right weight balance and tension to prevent blade drift. Even small choices like wheel size or tension bolts show the builder's understanding of real mechanics. Once the outer bark sections are stripped, the operator rotates the log to expose new cutting faces. That kind of manual control makes you realize how much intuition still matters in woodworking. Every adjustment feels deliberate. Nothing rushed, nothing wasted. Even without digital sensors, every board comes out nearly identical. Each blade moves in sync, slicing through the timber with impressive efficiency. This configuration doubles the output while maintaining smooth cuts. Operators monitor the feed rate closely to prevent overheating or uneven slicing. The coordination here is so precise that even a tiny vibration could change the cut's quality. You can almost sense the balance between raw power and control. Hard to imagine such precision coming from a homemade build. Cut slabs are stacked neatly for drying, while smaller offcuts are set aside for reuse. Sawdust gathers around the frame, pulled away by a side-mounted vacuum. It's not a spotless factory, but it's clean enough to keep the blade cool and true. Every detail of how it's maintained shows that reliability comes from consistency, not perfection. The operator doesn't need laser guides, just steady hands and an ear tuned to the motor's tone. That sound alone tells him more than any sensor could. The structure of this homemade saw is worth attention. Twin steel posts guide the top wheel, adjustable via a hand crank that keeps the belt tension even. Bearings are shielded with aluminum plates to block sawdust, extending life without complex maintenance. It's genius how simple adjustments solve problems that commercial designs often overcomplicate. Sometimes simplicity really does outperform sophistication. When the blade dulls, a small grinder sharpens it on site. No downtime, no outsourcing. That level of self-reliance defines why such workshops keep running. Every part is repairable, every fault fixable. The operator moves like he's in sync with the machine, feeding, measuring, trimming, and stacking in rhythm. Not bad for a setup built in someone's backyard. This thing cuts straighter than some shop models. By the end of the day, a pile of uniform planks stands where once there was only raw timber. Each beam carries the story of both ingenuity and grit. Machines like this homemade bandsaw don't just cut wood, they carve independence into every piece. It's the kind of craftsmanship that reminds you why small-scale engineering still matters. 400 square meters, 6 days, and zero waste. That's how TRIQ BRIQ redefines what fast build really means. Each wooden brick locks without mortar, forming over 400 square meters of living space. The method stores more than 50,000 kilograms of CO2, turning waste wood into a long-term resource. Who knew building fast could actually trap carbon instead of releasing it? Workers stack elements with simple tools, achieving speed and precision together. Eco-friendly, cost-efficient, and reusable. That's real circular construction. A modular idea turns into a real structure in Stuttgart, where the TRIQ BRIQ team tests their pilot project. Each compact wooden brick locks into the next, creating 50 square meters of wall in just 4 hours. Instead of relying on conventional materials, the builders use kiri wood and clay for the final layers, all designed for sustainability. Someone joked that stacking these blocks feels more like building giant Lego. The system's 3D connection allows even weak or damaged wood to become structurally strong. That's a smart way to turn waste into strength. Each piece arrives on pallets, easy to handle by any worker or crane. No chemicals, no heavy machinery, just efficiency and clean results. Pretty wild how construction can look this calm, yet change everything about carbon impact. The entire setup proves fast, safe, and reusable for future buildings. Strong roofs protect homes, but renewing an old roof challenges both skill and timing. Each inspection reveals hidden weaknesses that could compromise the entire structure. Schenk's team carefully inspects the timber frame before removing worn shingles, revealing the structure beneath. Old tiles are lifted and stacked, making way for new underlayment and insulation. Efficient coordination keeps the workflow smooth, even under tight schedules. Workers secure each board and membrane, ensuring tight seals against rain and wind. The ventilation channels are adjusted to maintain airflow, a subtle but vital step in long-term roof health. Not many projects balance speed with such attention to durability. Tiles are then placed, following exact alignment patterns that blend aesthetic appeal with functionality. Proper alignment is crucial to prevent future costly repairs. Flashing is installed around chimneys and roof intersections to prevent leaks. Each element is double-checked, and crews coordinate to maintain safety while optimizing workflow. Even minor gaps are addressed immediately, showing why attention to detail matters. Team communication ensures no step is skipped under pressure. Finally, the roof is finished with ridge caps and a last inspection, ensuring that the house is protected against seasonal challenges. Choosing the right materials can significantly extend roof lifespan. The care in these steps highlights the value of skilled craftsmanship. Witnessing the balance between manual labor and mechanical assistance reinforces trust in construction methods. Throughout, machinery supports lifting heavy materials while human hands guide precise placement. Energy efficiency is enhanced through insulation and ventilation adjustments, reflecting modern standards. Optimized airflow reduces energy costs while preserving roof integrity. The completed roof stands firm, combining traditional timber techniques with modern building practices. The way they manage both manual and mechanical tasks in harmony is remarkable. It's interesting to note how small adjustments can make a huge difference in overall durability. Cranes move, bolts tighten, and in just days, a full structure rises from timber precision. This CLT-based welfare facility in Japan proves how modular timber can reshape modern architecture without sacrificing strength or warmth. Built through the CLT pattern order method, each prefabricated panel is precision cut off-site, then lifted into place with millimeter alignment. Every connection is designed for strength and reusability, a true evolution in sustainable building. No wonder engineers are calling CLT the quiet revolution of construction. The assembly opens with ground-level panel positioning. Cranes lower each CLT wall section onto the anchors, while workers bolt the joints seamlessly. The first floor takes shape in a single day, ready for internal framing and service ducts. Someone would need to blink slower, just to keep up with the progress. That speed isn't chaos. It's coordination refined through engineering repetition. By the second day, vertical panels are already defining the second floor's perimeter. Steel reinforcements ensure rigidity, while insulation layers slot between CLT cores for energy efficiency. The roof modules arrive next, installed in sections to seal the structure. Each lift is synchronized. Timing matters as much as strength here. Once enclosed, workers move indoors to install electrical lines and finishes. The CLT walls, already treated against moisture, require no additional coating, making the site noticeably cleaner. Waste is minimal. Most materials arrive pre-cut, packed, and ready for assembly. That's the beauty of planned simplicity. Less dust, less delay, more results. By completion, the LAGOM facility stands as Japan's first fully CLT-modeled welfare building. Beyond its structure, it represents how thoughtful design can merge care, sustainability, and progress in one solid frame. The construction of laminated timber beams begins with a goal: durability built from nature itself. Selected pine logs are brought to the Grand Pine facility, where each one is inspected for density and straightness. The first operation cuts them into planks, with allowance for drying. In the drying chambers, the boards spend up to 10 days under automatic moisture control, reaching a stable 12% humidity. This ensures the wood remains strong and dimensionally true. After drying, each board is calibrated and inspected again. Defective parts are removed before the sound sections are cut to uniform lengths. These pieces then move to the jointing line, where finger joints connect lamellas into long beams. The jointing line feels like watching a perfectly timed puzzle come together. Next, a four-sided planer smooths every face, followed by glue application through a dual-component machine. The lamellas are stacked and pressed under a uniform 16 kilograms per square meter to create bonded beams. After curing for 72 hours, they're ready for secondary shaping. One viewer laughed, saying the press looked like it could flatten a car if it wanted. Finally, the beams are coated with protective compounds to resist biological effects. Seeing waste reduced and longevity increased gives a real sense of progress in modern woodworking. Timber modules roll down the line like giant building blocks ready for assembly. Each unit of the lattice project is framed, insulated, and sealed before being lifted for final assembly. The overhead crane deserves a coffee break. It never stops. Modules are carefully stacked and prepared for transport to St. Gallen. Pretty wild that entire rooms are constructed indoors and shipped out ready to join the site. Imagine a 3-bedroom house assembled in just 6 hours, ready for diverse needs. The compact panels lock together swiftly, surprising how stable the structure feels. Workers unfold pre-cut walls and fit them with minimal tools, creating a hybrid closed-wall system. It's rare to see a building so portable without sacrificing durability. Each component is designed for plug-and-play, enabling rapid deployment in emergencies. The wooden frame, sourced from Minnesota forests, forms a sturdy skeleton, while interiors slide in efficiently. Every house can be packed away for future use, ready to rise again. "5 days, a full house emerges from bare ground. Each crew member moves with purpose, turning plans into a tangible structure. Foundations are leveled and footings secured, forming the base for walls. Timber frames are lifted and joined, revealing the house's skeleton. Panels slide into place quickly, guided by both tools and teamwork. Efficient sequencing prevents delays and keeps everyone in sync. Roof trusses are installed, followed by sheathing and protective layers. Seeing a truss wobble slightly but stay upright makes the construction look like a clever balancing act. Temporary scaffolds help manage height safely, a detail that shows serious planning. Small adjustments during assembly ensure long-term stability. Finally, the house is inspected thoroughly, confirming that a livable, solid home stands ready in just 5 days. The speed combined with methodical execution is remarkable.